crack it.
Assalamualaikum warahmatullahi wabarakatuh. Welcome back to my YouTube channel. In this occasion, I will do presentation about electrical instrumentation of hydropower plant. Before we start a presentation, let me introduce myself. My name is Irfan Firmansyah. I'm 21 years old. This is my email, and I am an electrical engineering student at State Polytechnic of Malang. So let's go to the material. First, Indonesian technical hydropower potential is estimated at around 75,000 megawatt, with untapped resources concentrated on the island of Sumatra, Java, and Sulawesi. It is estimated that there is currently about 8 gigawatt of economically viable undeveloped hydropower potential, which will provide almost 33 trillion watt-hours of electricity per year. So, the hydropower is an electrical energy product took the power of moving water. Power obtained from the typical gravitation movement of water. Hydropower plant derive energy from the force of moving water and harness this energy for useful purpose. This is a type of hydropower plant. There are 4 main types of hydropower plant. That is offshore hydropower, storage hydropower, pump storage hydropower, and run-off river hydropower. That is a picture of pump storage hydropower. And then this is a picture of run-off river hydropower. For storage and offshore hydropower, I'm so sorry I didn't have a picture because I have to search in many sources but didn't meet the picture. I'm so sorry. And then this is a strength of hydropower plant. Number 1 is charging up variable renewable, and then low carbon and pollution free. Number 3, future projection. Number 4, low cost over the long term. And the last is hydropower and SDG. For your information, SDG or Sustainable Development Goals is a global action plan agreed by world leader, include Indonesia, to end poverty, reduce inequality, and protect the environment. The SDG has 17 points, like mean this, and from 17 point or goals, the hydroelectric project can directly support the achievement point 6, point 7, point 9, and point 13. After I tell you about strength of hydropower plant, now I want to tell you about a disadvantage of hydropower plant. For the disadvantage of hydropower plant is number 1, hydroelectric power is not perfect. However, and loss have some significant disadvantage. Number 2, hydropower is not polluting, but does have an environmental impact. Hydropower facilities can affect land use, home, and natural habitat in the dam area. Number 3, hydroelectric is hydrology dependent. And the last is, in some cases, the hydroelectric can disrupt with life habitat. And in some cases too, the hydroelectric can cause change the reservoir and stream water quality. After that, I want to tell you about the instrumentation and principle working of hydropower plant. This is a picture about hydropower plant. You can see that they have a 14 component, like number 1 until number 14 in hydropower plant. You can see that the reservoir, contour gate, rack until transmission. For reservoir is a building that it used to hold water before it is channeled to water canals. And then contour gate is a regulator of the entry of water into the penstock that goes to the turbine with its control from the control room. And then press rack is a function to filter various types of dirt so that it did not enter to the penstock. Number 4, intake is the water entry cap from the dam that will be flowed to the penstock. The penstock is a water tunnel made of construct pipe that product a pressure water flow to direct the flow of water to water turbine. Step-up trafo is an electrical component that used to step up and then transmit to the long-distance transmission line. The powerhouse is a place for turbine, generator, hydraulic equipment, valve setting, instrumentation indication, complementary equipment that support the operation of the hydropower plant. The generator is an electrical component that is used to convert the rotation generator from the turbine rotation to the electrical energy. The turbine is a mechanical component that is used to convert primary energy into mechanical energy in the form of rotation. And then a draft tube is required to carry water out of the turbine runner to the tail race. And the outflow is the water output channel from the finished penstock used to rotate the water turbine. A spillway serves to remove the excess reservoir water so the water did not overtopping, which can harm the dam. And then number 13, the fish ladder serves as mean the migrating fish so that the fish are able to pass through the height and get safely. And the last, the transmission line serves to distribute electrical energy from the hydropower plant whose voltage has been increased by the step-up transformer to the consumer. So after I tell you about a component, you must know about a principal work of hydropower plant. So in principal work, water in the reservoir enter the control gate and then will be filtered by the truck rack. After then, it is entered to penstock. So the water will turn the turbine and make a generator work. Because generator and turbine has been connected to other, and the waters exist into the draft tube and the end in a outflow. Back again to the generator. After work, the generator will produce electrical energy, which is the increase in voltage by the step-up transformer before finally going to the transmission line and ending in the consumer. After I tell you about a component, about a principal work, about a strength and disadvantage, about a type, in the hydropower plant have many components, but from the electrical component, we just have 3 electrical components. What is it? Number 1 is a generator, number 2 is transformer, and the last is transmission line. For a generator, in a hydropower plant, use a synchronous generator. What is synchronous generator? Synchronous generator is a electrical machine that convert the mechanical power from the prime mover into AC electrical power at a particular voltage and frequency. The synchronous motor or synchronous generator always run at as constant speed, called synchronous speed. And the working principle of synchronous generator is use a Faraday law of electromagnetic induction. Electromagnetic induction states the electromotive force induction into the armature coil if it is rotating in the uniform magnetic field. The EMF atau magnetic field will also be generated if the field rotates and the conductor becomes stationary. Thus, the relative motion between the conductor and the field induction, the EMF in the conductor. The wave shape of the induction voltage it always sinusoidal curve. And this is a contraction of synchronous generator. They have three main component. It means stator, rotor, and the air gap for space from stator and rotor. Next, this is a stator construction. It have four main component. That is the frame, the actuator core, the actor core, the groove, and the actor winding. And this is a rotor construction. The rotor construction is different by two. What is it? Number one is the cylindrical pole type for high-speed generator consists of groove for the field coil. The furrow are divided into the polar planes. So in this picture, the cylindrical pole is mean in this picture A, and then the picture B is a silent pole type for low and medium speed generator. The protruding pole consists of a pole core and a pole shoe. The field winding is wrapped around the body of the pole. On the pole shoe, a damper winding is also installed. The pole winding are made of copper, while the pole body and the pole shoes are made of malleable iron. So, in the hydropower plant, we use this figure B, that is a silent pole. Why? Because in the hydropower plant, the speed is maybe low and medium. So if you use silent pole, it's very good. Now that is a picture of silent pole like this. Next, transformer. Step-up transformer is a type of transformer with a function of converting low voltage and high current from the transmission primary side to the high voltage and low current value to the secondary side. The characteristic of step-up transformer is number one, the number of turns in the primary coil is always less from the number of turns in a secondary coil. Number two, the primary voltage is always less than the secondary voltage. And the last, the primary current is always greater than the secondary current. And the last is transmission line. Transmission line is used for a transmission of electrical power from a generating substation to the various distribution unit. It transmits wave of voltage and current from the one end to the another. The transmission line is made of a conductor having a uniform cross-sector along the line. For transmitting high voltage, overload distinct high voltage direct current is used in the transmission line. After I tell you about electrical component, now I will to tell you about control in power in hydropower plant. The control actually have many control in hydropower plant, but in this presentation I will to tell you about DCS or distribute control system. DCS or distribute control system is a specially designed automatic control system that consists of a geographical distributed control element over the plane or control area. It differs from the centralized control system, wherein a single control at a central location handles the control function. But in the DCS, each process element or machine or group of machine is controlled by a dedicated control. DCS consists of large number of local controllers in various sections of plane control area and connect via a high-speed communication work. The architecture of distribution control system. We have three architecture of distribution control system. The first is the distribution of various control functions into relatively small set of a subsystem with other semi-automation and are interconnected to the high-speed communication bus. Number 2, the second attribute of DCS is the automation of manufacturing process by integrating advantage control strategy. And the last and the third is arranging the things of a system. DC organizes the entire control structure as a single automation system where various subsystems are unified to a proper command structure and information flow. The attribute of DCS can be observed in this picture. That is, have 5 attributes or 5 basic elements in a DCS. That is a engineering workstation, operating station or IME, process control unit or local control unit, smart device, and communication system. Number 1, engineering workstation. It is a supervisory control over the entire discrete control system. It can be a PC or any other computer that have the data in engineering software. For example, control breather F in this picture, like this. This is a engineering workstation. And then number 2, operating station or HMI. This is used to operate, monitor, and control plant parameter. It can be a PC on any monitor device that has a spirit software tool on the which operation can view process parameter value and accordingly to take control action. For instance, it is a DGV software tool that can run for a simple PC in case ABB DCS, like this. This is a operating station or HMI. And then number 3, process control unit DCS. It is also called of a local control unit, distribution control, or process station. A distribution control system can consist of one or more process station that can be extended with different type of input or output unit. This control consists of a powerful CPU module, field bus or communication module with extended field bus capability and either direct or remote control input or output. The field device like sensor and actuator are connected to input and output module of this unit. And then number 4 is communication system. The communication medium system is a major role in the inter-district control system. It is interconnect the engineering station, operation station, process station, and smart device with one another. It carries the information from the one station to other. The common communication protocol used in DCS include Ethernet, Profibus, Foundation Field Bus, DefiNet, and Modbus. And the last number 5 is a smart of intelligent device. The intelligent field device and field bus technology are advanced features of DCS technology that replace traditional input or output subsystem. The smart device and the intelligence required for simple sensing and control technique into the primary sensing and actually device. And hint is replaced to the need for the DC controller to perform routine sensor and control process. After I tell you about a component in DCS, I want to tell you about working and operation of DCS system. Working and operation of DCS system. First, sensor sense the process information and send into the local input and output module, to which actuator are also connect so as to control the project parameter. And then the information or data from this remote module is gathered to the process control unit via field bus. After then, if smart field devices are used, the sense information directly transferred to process control unit via field bus. Then the collected information is further processed, analyzed, and produces the output result based on the control logic implemented in the controller. Then the result of control action are then carried the actuator device via field bus. After that, the DCS configuring, commissioning, and the control logic implementation are carried at the engineering station as mentioned earlier. And last, the operator able to view, send, control, action manually at operation station. Maybe just it. Who can I tell to you? I'm so sorry if many mistake, if many less in this presentation, but I'm so thank you if you attention me to listening my presentation. Before I finish this presentation, I will tell you about my reference. You can see this my reference, and this is a shot of picture of my reference, and maybe just that. I say thank you for your attention. I'm so sorry if many mistake, if many trouble for the PowerPoint, and I want to say don't forget to like, comment, share, and subscribe. Bye bye.